Okay, so welcome to my part 3 of my Honors Algebra 2 progress check for quarter 1. This is going to be Unit 1, topic 3, and then formative assessment number 1. So if we take a look at this formative assessment, this deals with exponential functions, so most likely you'll be using some of the formulas that will be given to you in terms of exponential growth, exponential decay. So a lot of these types of formulas hopefully will be given to you. So it says write an exponential model that represents the number of cell phone users in the United States where t represents the number of 10-year time periods since 2000. So the base of your exponential model should be correct to 3 decimal places after the decimal point. Okay, so the first thing I need to organize here is that t is going to, in a sense, be represented by 10-year increments. So if I organize this, if I say t is equal to 1, it really means that that is going to be 10 years. And then if I said t is going to be equal to 2, that is going to be 20 years. Okay, so what I want to do is I want to try and organize some type of model that represents this, but most likely, probably what I want to do first is I want to actually find the percent rate of change. So I do know at 2000 that there are 109. So I'm going to use the model A is equal to A naught, or the initial A value, parentheses 1 plus R. More specifically, since I know that the value actually went up, so I'm going to do 1 plus R, and then to the t power. Okay, and then this is where we need to get our values correct. So I'm going to place the amount after that 10 years, so that's going to be 3,000 or 300 into that specific spot. Then the initial value, which is going to be 109, parentheses 1 plus R, and then raised to the, so if it is 10 years later, then I'm going to actually have my t is equal to 1. So I'm going to divide both sides by 109, divide both sides by 109, and I should end up getting the value. Let's see what I get. I should end up getting the value 2.752. Right, so 2.752 is equal to parentheses 1 plus r to the first power. But here's the deal, ready? So if it's just raised to the first power, I don't need to worry about doing a square root or cube root or whatever. So I can actually just make the parentheses go away, subtract a 1, and so I end up getting a rate that is going to be equal to 1.752. So if I think about this in terms of a percent, this is actually going to be 175.2%. So that means what percent rate of change is this going to be after every 10 years? This is going to be 175.2%. Now, to actually write my model that they're saying for the 10-year increments, this is going to be A is equal to, so that's starting amount, so 109 parentheses 1 plus, and so I'm going to say 1.752 to the t power. So that is going to be my model. Okay. Now, after that, it says change your model to show that the growth in the number of cell phone users each year. So the base of your exponential model should be correct to 3 decimal places after the decimal point. So instead of saying t is going to be equal to 1, this is going to stand for now 1 year. Okay, so if t is equal to 2, then that's going to be 2 years. So, but I don't know the specific rate for the actual for each year, so I'm actually going to figure out what d is first before I actually develop my c. So I'm going to start off with my equation, so I'll say that same thing, so 300 equals 109 parentheses 1 plus my r, but I technically don't know what my r is because this is going to be changing each year. Now, it makes sense to maybe just say, okay, well, I'll just divide that percentage by 10, but that's not how the exponential functions end up working. It's a little bit different from there. But what I'm going to do here is, since going from 109 million cell phone users to 300, I know that that is actually going to be 10 years later, so I'm going to write that as 10. Okay, so from here, I'm going to divide both sides by 109. Divide both sides by 109. So I still should end up getting the value 2.752 is equal to parentheses 1 plus r to the 10th power. Now, how do I get rid of something to the 10th power? Well, I have to do the 10th root. So the 10th root. Now, to do this in your calculator, what you want to do here is you want to do 2.752 caret, and then raise it to the 1 divided by 10 power. And so what that will do is that will give you the rate that is going to be equal to, and some of you guys might have something a little off than what I have, but you should end up getting something around 0.107 or 6, depending on how you rounded. So which is going to end up giving you a 10.7% increase. So what is the percent rate of change for each year? Yet again, this is just for each year, not every 10 years. So this is going to be 10.2% or 10.7%. So my equation over here is going to be the following. It is going to be y equals 109 parentheses 1 plus r, which is going to be 0.107 raised to the t power. So that is per year. Per year. Okay, so then moving on to the next one, it says, use one of the models to determine to the nearest million how many cell phone users will be in the United States in 2020. So you can use whatever model that you want. The only difference here is if you're going to be using this model, remember that's going up by 10. So if this is from 2000, then we would use 2 here, right, because it's 20 years later. Or if we were using this model, we're going to say that it's going to be 20. So we're going to say y equals 109 parentheses 1 plus. So what would you want? So let me just use that 175.2%. So I'll do 1.752 raised to the second power. So I end up getting, oh, I don't know why I'm saying y. This should be amount. So the A value here is going to roughly be around 825 million users to give me that value. Okay, so moving on. So here's the e to the x graph, right? So this is, in a sense, our normal parent exponential function. So the domain, all real numbers. The domain is from 0 to infinity. No, that's not true. The range is all real numbers. Nope. The range actually is going to be from 0 to infinity, right? Because we're starting at the y value right here, and then it's going up. It also has a horizontal asymptote. Oh, which, speaking of which, we're going to have a horizontal asymptote at y is equal to 0. Okay, so those are going to be the characteristics of the graph. It's also kind of nice that they actually give you the graph to go along with this, so you don't have to really do any guessing games. And it says solve the equation, use your answer. Your answer should be correct to 3 decimal places. Use the coordinate grid to provide should you choose to solve it graphically. Okay, so with this graph, I'm going to end up dividing both sides by 3. So 3's cancel. So I'm now left with 2 to the x is equal to 5. So now how to actually figure this out, what I'm going to do here is I'm going to say y is going to be equal to 2 to the x, and I'm actually going to have like a y1 and then a y2 is going to be equal to 5. So if I were to actually graph this graph, so 2 to the x, so that means I have a point at 0, 1, 1, 2, 2, 4, 3, 8. And right, so what I'm doing here is I'm giving my exponential graph right here, like this. The next thing what I'm going to do here is I'm going to try and do my best at, I have this y2 is equal to 5, so that is going to be my horizontal line that kind of comes across right here. And I'm going to focus on where is that intersection point between the two. So it looks like that it's a little bit closer to 2, maybe 3. So I'm going to actually just say that that's maybe going to be like 2.1, maybe 2.2. So I'm going to say x is going to be roughly equal to, let's say, 2.2, or maybe even say 2.3. Right? There's no real way of getting that actual value kind of by hand that we know of just yet. The only thing that really I could do with this problem is kind of guess and check to kind of go from here. Okay. Okay, moving on. Oh, you can also, by the way, if you do have a calculator to be able to figure these values out, right, you can still set those in and actually get the intersection by using your calculator to get the intersection of those two values. The actual value that it should be x is equal to 2.321, or you could also say 2.322. I forgot that maybe this specific formative assessment could probably use calculators, but I'm guessing if you're using all these different decimals and stuff, you probably would be able to have a calculator for this. So that's how you could figure it out. Okay, it says Moria plans to deposit $1,000 into a bank account and leaves it in the bank to gather interest for 5 years. So she researches the interest rate at 2 banks. Her findings are shown below. So her interest rate is actually for both of these, but compounded monthly and compounded quarterly. So compounded monthly means the end value is going to be 12, and compounded quarterly, which means the end value is going to be 4. So which bank should she choose? So let's organize specifically for Bank A and Bank B. Now, some of you guys might know the answer right off the bat, because when you're compounding it more times, you'll end up getting more money. But it's really not very much more money, so we'll just kind of go from there. So the formula that we're using, I'll write it over here. So the amount is equal to principal times 1 plus r over n to the nt power. So for Bank 1, I'm going to say the amount is going to be equal to the principal, which is $1,000. That's how much he's depositing into the bank. Then we're going to say 1 plus the rate, which is going to be 0.04. Remember, we move it 2 decimal places to the right, to the left, and then over 12, and the raised to the 12 times, and then this is going to be for 5 years. Okay, so the amount that I should get after that specific amount of time should end up becoming the 1,220 and 99 cents. Now for Bank B, it's pretty much the same setup, 1,000, parentheses 1 plus 0.04 over 4 this time, and raised to the 4 times 5 power. Now, when you're plugging this into your calculator, you need to remember that when you put this as a caret, especially if you do not have a TI-84 calculator where they actually show it as the exponent, you need to make sure that this is wrapped in parentheses. So start off the 4 with a parentheses, regardless if you do have a TI-84, just in case. So the amount here is going to end up giving us $1,220. So, like I said, very similar, but this actually ends up giving you 19 cents. So which one is actually a better deal? It is Bank A, but only by, 80 cents. So it's not really that much of a difference. But hey, 80 cents is, 80 more cents in your pocket is good. So it says, Moria finds a bank C that offers 4% compounded interest continuously. Explain why Moria should or shouldn't choose Bank C. So this formula is going to be A is equal to PE to the RT power. So we're going to say the amount is equal to, so 1,000, E to the rate, which is going to be 0.04, and then times T, which is going to be for 4 years. And so this specific amount is going to end up being, we're going to be left with $1,221.40. So, should they choose Bank C? And the answer would be yes. And more specifically, right, the number of times compounded, right, the more times you compound per year, the more amount of money that you'll get. Not a significant amount, but definitely a more amount of money. Okay, so which represents exponential decay? How do you know? So the thing that you want to focus on here is looking at our normal equation. So it is y equals a b to the x. That's kind of one of our normal standard exponential equations. So if b is going to be greater than 1, for example, that will be exponential growth. Now, that also means that the x value is going to be positive. As soon as the x value is negative, what it does is it flips the b, makes it the reciprocal of that. So for the first one, b is in a sense 2. So if that's greater than 1, that is going to be growth. Now taking a look at this, notice how this b value is not greater than 1. So if it is between 0 and 1, this is going to be exponential decay. So this value is going to be decay. Now the last one, notice how it has a negative exponent, so I would actually write this as 1 over 2 to the x power, right? Because it flips that base to its reciprocal. And so since the b value now is 1/2, this is also going to be decay. And in fact, these two problems, or these two equations, are actually going to be the same. And lastly, taking a look at this, so it says the price of gold has grown exponentially in recent years. Determine an equation that would model this growth using the graph below. Show how you determined your equation. So this is really just taking two order pairs from this graph and then writing an equation based around that, using, in a sense, the formula y is equal to ab to the x power. So I'm going to start off by kind of labeling what this point is. It's probably not the best indicator of where this is going to be, especially since they don't have any 2 tick marks, but I'll let you know that this order pair is actually going to be 0, 250. And that sort of does look like that is going to be 250. The next one at 3 at this specific point looks like that is going to be 400. So I have 3, 400. Now, there's no other points that really kind of give a clear indication of where this exponential graph is going to kind of perfectly line up, so we're going to use these 2 points to kind of help us along. Yet again, you could have actually tried to estimate even better. Maybe I would have said maybe 300 right here that you could have used at 1, but I'm going to just use these 2. As long as you're something relatively close, you should be okay. So since I'm actually choosing the 0 value here, I'm going to set up an equation that will be y is equal to a b to the x, and place in my y value as 250 is equal to a b to the 0 power. So the x value is going to be 0. Now the interesting thing about this, right, b to the 0 is actually going to give us 1, so therefore a is actually going to be equal to 250. So we actually fill in a part of our equation. Y is equal to 250 b to the x. Now we need to figure out what the b value is, so how do I figure that out? Well, there's a couple ways about approaching this, but really I could just use this equation to kind of help me along. So I'm going to place in the 400 is equal to 250 b to the 3rd power. In a sense, I'm placing in the x and the y value. So I'm going to divide both sides by 250. I end up getting the value 1.6. I get 1.6. Is equal to, and I'm going to get b to the 3rd power. Now, to undo that cube, I'm going to do a cube root. So I end up getting my b value is going to be roughly equal to 1.1696. So therefore my equation is going to be y is equal to 250 parentheses 1.1696 to the x power. And there's my equation. Well, thank you for watching my third formative I ended up going through. I hope you guys learned something. If you have any questions, please feel free to leave a comment down below, or just some comment in good faith that you learned something out of this. I hope you enjoyed watching it, and I hope you have a good day.